All right, so 5.2 part 2. So we talked about this yesterday. We can't have a radical in our denominator for our answer to be in simplest form. So one way that we can get rid of the radical in our denominator is by multiplying by the conjugate of it. So if I had something like 2 plus square root 5, what would the conjugate of this be? 2 minus square root 5. What if I had the square root of 3 minus the square root of 4? What's the conjugate of this? So the square root of 3 plus the square root of 4. So these would be conjugates of each other. The first term always stays the same. The sign in the middle is what changes. So we are going to write 1 over 5 plus square root 3 in simplest form. So we have to multiply the top and the bottom by the conjugate of our denominator. So what would our conjugate of 5 plus square root 3 be? 5 minus square root 3. And whatever I multiply on the bottom, I also have to make sure I multiply the same thing to the top. So 5 minus square root 3 on the top. Now let's multiply out the bottom. So you can FOIL or you can do the shortcut. The shortcut is the first term squared, always minus the second number squared. So it's 5 squared minus square root 3 squared. Always minus in the middle. So what's 5 squared? 25. Minus, what is the square root of 3 squared? 3. The square root and the squared cancel, so it would just be 3. And 25 minus 3? 22. So that would be our denominator. On the top, if our number wasn't 1 on the top, you would either FOIL if you had like 2 terms on the top, or you would distribute. But here it's just 1, so 1 times anything would be itself. So on the top, we get 5 minus square root 3. And what did I get for the denominator? 22. So this would be our answer. All right, let's look at the next example. In example 6, we're simplifying variable expressions. So here we have our radicals, but we're just going to have variables on the inside also. So we're going to simplify the expression. You can do the number first and then the variable, or just do it all together. We'll start with the number. What are 2 factors of 64? 8 and 8. And 2 factors of 8? 4 and 2. And 2 factors of 4? 2 and 2. I'm circling how many of a kind here? 3 of a kind. So do I have 3 of a kind? I have 3 2's and another 3 2's. So what's going to come to the outside? 2 times 2. So that would be 4. So 4 comes to the outside. Now let's deal with our variable part. How many y's do I have here? 6. If it helps you write them out, I have 6 y's. How many of a kind am I circling? 3 of a kind. So I have 3 y's here and 3 y's here. So how many y's come to the outside? 2, because I have 2 circles of them. So 2 y's would come to the outside. So how would I write y times y? Y squared. So my answer here would be 4y squared. So example B, what should I do first? I could split them up, so take the 4th root of x to the 4th power over the 4th root of y to the 8th power. We can treat it separate. Let's see if I can break down the first one, the top. So if I have the 4th root of x to the 4th power, how many x's do I have here? 4. I'm circling groups of how many? 4. So how many x's would come to the outside? 1, because I have 1 circle. Let's do the same thing with the y's. How many y's do I have inside here? 8. So if it helps, write them 8 times. And I'm circling groups of how many? Groups of 4. So I have 2 groups of 4. So what would come to the outside? Y squared, because this would be y times y. All right, so let's look at the next page, A. We're doing the same thing, we just have more variables here. So if it helps, write out everything that you have. So what are 2 factors of 4? 2 and 2. I'm circling groups of how many here? Groups of 5. Do I have a group of 5 2's? No. So I know that I'm going to have a 4 that stays on the inside. So the 5th root of 4 is going to be my answer because I can't take that 4 out. But let's see what else we're left with. How many A's do I have? 8. I'm circling how many of a kind? 5 of a kind. So I have 5 A's. And how many left over that didn't get circled? 3. So how many A's would come to the outside? 1, because I have 1 circle. So 1 A comes to the outside. How many have to stay on the inside? 3. So A to the 3rd power stays on the inside. All right, how many B's do I have? 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm circling how many of a kind? 5. Thank you. So I have 5 B's here, 5 B's here, and how many left over? 4. So how many come to the outside? 2. So I have B squared on the outside. How many have to stay on the inside? 4. So B to the 4th power on the inside. And then how many C's do I have? 5. 1, 2, 3, 4, 5. I circle how many? 5. So how many come to the outside? 1, because I have 1 circle. How many stays on the inside? None. So this would be our answer. Another way that you can work this out instead of writing them all out would be to divide. So if I had 8 A's, I would say A to the 8 divided by 5. And you could think, how many times does 5 go into 8? Once, with 3 left over. So 1 would come to the outside, 3 has to stay on the inside. So you can divide it and think about it that way, or you could just write them all out. Either way, I think writing them out is easier to see, but if you can do this in your head, it might just be easier to divide it. So either way works. So adding and subtracting variable expressions. We can add or subtract with our radicals only if they are exactly the same. So we have talked about this before when we did this in our pre-chapter stuff. But if your radical is exactly the same, you can add these two together just by adding the coefficients and the variable part stays the same. So what would I get when I add these together? 11 square root y. So when your variable parts are the same, we add the coefficients together. What if I had something like 3 square root x plus 3 square root y? Could I add these together? No, because the variable parts aren't the same. So these are not like terms, so you can't add it.